Congratulations. So let me first thank you, 6G Alliance, and in particular Pathak Sahab for starting the Tech Talk series. Every fortnight, I said, will be some or other talk on 6G and other technology. So thank you for doing that, and it will be really beneficial for all the stakeholders. And also, I would like to congratulate you on the first anniversary of 6G Alliance. So congratulations to entire 6G Alliance team, and in fact, congratulations to all of you, because I mean we all feel part of it, and let's see that we bring 6G in our country, and also we export to the world. So with this, let me upload my PPT. Give me a moment. So please confirm if the PPT is visible. Anyone?
Yes, sir. It is visible, sir.
So thank you. So as topic given to me is ITU vision and framework for IMT 2030. So let me begin straight away. So let me first take a pointer. Let me first tell you that uh, every generation of mobile communication, so it takes almost 10 years to evolve from one generation of mobile to the next generation of the mobile. Uh, and On the same line, like ITU, that 6G will also take almost 10 years till it is commercially launched. So the journey started in 2021. You can see the timeline on the screen. So journey started on 2021 when ITU started working on creating framework and vision for 6G. So it's a 2 years process. You can see on your screen that initially ITU issues a future technology trend. So with the help of experts, what are different technologies which are trending or will become a commercial thing in future. So those are discussed, and a report is taken out, and then it also issues the framework and vision which is required. In addition, uh, ITU is also working on feasibility of using IMT, that is mobile communications, beyond 100 gigahertz of the spectrum. So this is the first part of the framework and vision which is now done with. The next stage is about creating technical performance requirement of 6G radio, and how that performance requirement would be evaluated once 3GPP and other SDOs are able to build the specification and standard. So this is also a almost 2 years period. After 2026 onwards, parallelly 3GPP and other SDO would be working in developing the standard, and maybe around 2027, 2028, uh, the 3GPP and maybe some other SDO would come back to ITU and submit their technology for 6G, which ITU evaluates and declare that as a 6G technology, or IMT 2030 they call. So ITU terminology for 6G is IMT 2030. So we can see the first phase of deployment of 6G maybe around 2029 and 2030, by the time the standards are also published by ITU, and 3GPP standards are parallelly, vendors are actually working to also create the commercial system. So by 2030, we can see some commercial rollout of 6G system. So it's a four-step process: framework, requirement, then evaluation, and a fixation of specification, final approval, and the launch. So the first part, the vision and framework, which ITU has already published, I'll be talking about that. So it starts with creating some usage scenario. So based on different stakeholders, all the 193 plus country and other members of ITU have decided that what usage scenario 6G would be handling. So if you look at this, they have decided, or they have, I mean, through the process of consensus, decided that 6G would generally have six usage scenario. Out of the six usage scenario, three are extension from 5G, that is IMT 2020. So in 5G, we had enhanced mobile broadband. Now that will be uh, expanded as immersive communication. 5G had massive machine type communications. Now it will be called massive communication in 5G. Uh, Ultra reliable low latency communication in 5G is now will be enhanced to hyper reliable and low latency communications. So, in addition to these three usage scenario extended from 5G, there will be three new usage scenario in 6G, and they are ubiquitous connectivity. This was in fact pushed by India. So uh, we at ITU pushed this particular requirement to be part of the usage scenario. The next two are integrated AI and communications. That means we are talking about having native AI functionality onto the 6G network. And then we are talking about the sixth user scenario as integrated sensing and communication. So sensing traditionally has been a separate vertical or separate entity. Now we will try to converge communication and sensing together with this particular usage scenario. On the top of this six usage scenario, ITU has also decided to have four overarching aspect. When we say overarching aspect, we are saying that there will be a design principle applicable to all these six usage scenario. They are sustainability, connecting the unconnected, ubiquitous intelligence. So intelligence should reach to everyone, not only urban population but even the rural population. And finally, security, privacy, and resilience. These four overarching aspects would apply to all the six usage scenario. Now let's talk about these usage scenario and the capability required to support these usage scenarios. So if you look at this palette diagram given by ITU, it talks about six enhanced capability of 5G. So in terms of peak data rate, user experience data rate, spectral efficiency, area traffic capacity, connection density, mobility, latency, reliability, and security, privacy, and resilience. So these were already part of 5G. So these capabilities are in fact enhanced for 6G. The target given are enhanced target. In addition to meet the three new usage scenario, the six new capabilities has also been talked about, and they are kind of a coverage to meet ubiquitous connectivity, sensing related capabilities, AI related capabilities. Sustainability has come as one of the capability, interoperability, and the positioning, which is very, very important. So let us talk about each of these capabilities in detail and what kind of usage scenario they will be supporting. So starting with immersive communications. So for immersive communications, what are different capability which may be required? So let's start with peak data rate. So peak data rate is something which will be very important for immersive communications. And as we know, in 5G, ITU has had defined 20 Gbps downlink peak data rate, whereas for 6G, these are targets for 6G, not the actual requirement. Actual requirement will come maybe next year sometime. So the target this time is a staggered one. It's not a one absolute value. So they have said 50 Gbps, 100 Gbps, and 200 Gbps. So that means they will go 10 times from 20 Gbps to 200 Gbps, maybe in a staggered timing in different releases they will talk about. The other important parameter for immersive communications can be user experience data rate. And as we know that for 5G user experience data rate, so data rate which should be available across the coverage area, maybe even at the edge of a coverage. So that was 100 Mbps for 5G. For 6G, target is 300 Mbps, and it can move up to 500 Mbps. That means it will go 5 times better compared to 5G. In respect of spectral efficiency, that in 1 hertz of the frequency, how much data rate one should be able to achieve. So the target here is 45 bit per second per hertz, and it can go up to 90 bit uh, per second per hertz, which is 3 times better than 5G. 5G it was 30 bit per second per hertz. So in every aspect there is enhancement. Area traffic capacity, which was 10 megabit per second per square meter, whereas for 6G the target is go to 30 and then to 50 megabit per second per square meter. uh, Mobility, so mobility is something when we travel in our car or in a train or in a bullet train, our mobile should actually work. So mobility up to certain speed only technology supports. For example, 4G supports a mobility of 350 kilometer per hour, and 5G the target was 500 kilometer per hour. In 6G we are talking about that 6G phone should actually work even in a vehicle which is running at 1,000 kilometer per hour. It's a very huge enhancement, and that will really help roll out mobile services in a moving kind of environment. So these were kind of a capability which would be supporting immersive communications. Now let's look at different capability which is required for supporting massive communications. So starting with connection density. So when we say connection density, what it means is that in a per square kilometer, how many say IoT sensors, other objects or machine can connect to the network. So that's a requirement coming up, because in future we see that every object, every machine, everything would get connected to say network. So the connection density supported in 5G was defined as 1 million or 10 lakh devices per square kilometer. In 6G, we want to go up to 10 crore devices per square kilometer. It's a very huge research target which has ITU has given in its vision document. And let's see what exact number is defined in the requirement document next year. To support hyper reliable low latency communication, that is HRLLC, the first requirement is on latency. As we know that 5G, we are talking about 1 millisecond latency for URLLC type of requirement, whereas in 6G, the target is to go up to zero point 0.1 millisecond, 10 times better compared to 5G. That's the target given to study and uh, uh, include in the requirement document. And the reliability, so reliability is measured in terms of say packet error rate. So when I transmit some data to you, how much data you are able to receive correctly and how much is the error. So in case of 5G, we have seen that 3GPP standard, if you look at, they have talked about 10 to the power minus 6 also in some of the URLC applications. So that means only one bit of error in 10 lakh bit transmitted. In 6G, we are talking about 10 to the power minus 7. If you translate that into percentage, it comes to 99.99999. That is kind of a 7-9 kind of a reliability we are talking about in terms of packet error rate and also in terms of availability. That's the reliability which is required for HRLLC kind of applications we are talking about. And then positioning is also very important requirement coming up to the mobile. Till now we had been majorly focusing on GPS technologies, but GPS technologies have limitations. It doesn't work inside a environment unless a satellites are visible. You don't have good positioning system, but 6G or even 5G advanced can do some sort of positioning. So here target given is up to 1 centimeter accuracy 6G to support. So the next, the fourth, you say scenario, you talked about ubiquitous connectivity. For ubiquitous connectivity, coverage is the requirement, technical requirement given. As we know that India had developed its own 5G technology called 5GI, mainly to meet large coverage where we had proposed pi by 2 kind of a modulation and some other techniques. So 6G also, this requirement has come as a ITU requirement. Maybe our industry, our academia would be pushing certain technology for India so that we have a larger coverage from the cell, so that services are available to more and more remote and rural customers. For integrated sensing and communications, so the requirement which ITU is talking about, that we should be able to judge range or velocity of a particular object or angle estimation, detect an object, we localize those objects, imaging, mapping, all those sensing capability which was a separate vertical earlier, now it will converge into mobile communication itself to some extent, or maybe going forward to a large within the 6G network. Can we have distributed data processing? In fact, we already have edge computing in 5G, so those are becoming a possibility. Distributed learning, AI computing, AI model execution, AI model inference, and all the technique which we have in AI, can we like have natively available into the 6G network? So that's the target which we have today. In terms of interoperability, what ITU has talked about, that from different technologies, different radio technology, they should talk to each other today. Although we have kind of a XN interface or X2 interface in 4G and 5G, but practically those are not working between different vendor. So can we have that interoperability as a one of the important requirement of 6G, so that interoperability aspects are taken care of. Now, finally, coming to the design principle, as we talked, that all those six usage scenario in this wheel diagram is now covered by those design principle, which are kind of a sustainability, connecting the unconnected, ubiquitous intelligence, security, privacy, and resilience. So ITU has talked about security, which are traditionally uh, confidentiality, integrity, and availability. How we can build that? These are already there in 4G and 5G. How we can better enhance? And today, one of the aspects is how we can make these quantum safe. Would be some of the things which we should think of. Then privacy, so protection of individual personal information or personal privacy is one of the requirement or overarching principle which should apply to all the six usage scenario. The second point in privacy is very important, that in case my data is used, for what purpose it is being used, when it is being used, I should be informed. So that means my data can only be used with my consent, right? So that's a very important aspect which is coming onto the design principle of mobile communications. That's very good that we will actually cater to all the privacy need. And of course, the resilience is very important. In case of any man-made disaster or maybe natural disaster, our network should continue to work. For example, if there is a loss of primary source of power, we should have enough arrangement of secondary sources that communications continue. So resilience is also one of the overarching or design principle of 5G. In respect of sustainability, we are talking about how we can build the 6G network, which is very, very energy efficient. Although 5G is supposed to be much more energy efficient than 6G. In 6G, we are talking about having completely green kind of technology, how we can minimize energy consumption and use the minimum of the resources. So those are the sustainability aspects we have to take care of. So with these usage scenario and the capability of 6G, which ITU has talked about, so what kind of new services we are looking for in 6G and beyond, so that some of the usage, actual use cases can be holographic communications. That means mobile based holographic communications. I can take holographic communication to my office, to my home, wherever I go. Tactile and haptic internet applications, mainly for industry and other use cases. Uh, the convergence of compute and network. So today we are talking about edge computing. So can we have computing and network convergence, which has already started in 5G, that will consolidate. How we can have very high data rate access, uh, connecting everything, connectivity for everything, so that ubiquitous coverage thing. And then vehicle to vehicle, vehicle to infrastructure communications, extended reality, multi-dimensional sensing, digital twin, machine type communication, proliferation of intelligence, and seamless coverage, global seamless coverage. So these are kind of a new area. So what are different opportunity for us? What are different opportunity for India, and of course for the world? We are already working, but let us talk about that. First of all, what could be different technologies to make 6G network AI native? What can be different technology wherein I can have integrated sensing and communications? These are basically research area where our industry would be working, our academia would be working and contributing to 3GPP to include our IPR, our SEP technology to support convergence of communication and compute. What are different technology for device to device communications we are already doing in 5G and 5G advanced? How we can utilize the spectrum very efficiently? Somebody is talking about a blockchain based spectrum sharing and all. How we can have energy efficiency concept, how low power consumption particularly in IoT devices would be possible, how we can support natively real time services and communications. So technology for that, technology for trustworthiness, that is security part of it. What enhancement radio interface need, whether we want to reuse the same OFDM waveform, you want to bring in some new waveform for 6G, what could be modulation technique we'll be using, what kind of different antenna or advanced antenna we have, talking about cell-free massive MIMO, whether that will become part of 6G, what technology India can bring onto that. We are talking about full duplex in a TDD environment, in band kind of a full duplex. So, what kind of technology we can develop onto that, and so on. So there are many things. One of the buzzword today is the terahertz communications, and we are supporting terahertz communication research and product development from DOT side, as you know. So whether we can develop or create our own transmitter and receiver in terahertz, what kind of use cases we can create using the terahertz technologies. Then technologies for accurate positioning. So these are all kind of a area of research which you can see here: RAN slicing, uh, uh, maybe digital twin. One of the important is integration of non-terrestrial network. That means how a satellite communications can become part of our mobile communication. There can be a seamless roaming between terrestrial and satellite and so on, so that we are able to cover unconnected area. Uh, so these are kind of research area where our researcher can uh, uh, develop the technology, develop the product, and put it into the 3GPP standard, and we put our own IPR and SAP out there. So thank you. That's the end of my slide. In case you have any question, or maybe I hand it over to Asta for further anchoring it.
Thank you so much, sir, for such an insightful talk. The IMT framework could never be like simplified and explained in such a simple manner as you have done. So, moving ahead, we will be starting with our next presentation, sir. Um, so now we move on to a second guest speaker, Mr. Rajesh Kumar Pathak from Bharat 6G Alliance. Mr. Pathak, with a master's degree in technology and over 37 years of distinguished experience in senior positions within the government of India, is a visionary leader renowned for his exceptional contributions to indigenous manufacturing, technological innovation, and global collaboration. As a pivotal force behind the establishment of the Telecommunication Standards Development Society, India, he has been instrumental in driving technology standards and fostering innovation. Mr. Pathak's strategic insight and leadership have significantly advanced the Make in India campaign, nurturing Indian startups and promoting technological self reliance. Before his current role as Director General of Bharat 6G Alliance, he served as Bharat 6G Mission Head, where he played a key role in formulating the Bharat 6G Vision Statement. Under his forward looking leadership, the Bharat 6G Alliance continues to shape India's telecom landscape, inspiring innovation, collaboration, and progress. Today, he will share insights on the topic driving 6G breakthroughs, building synergies, and accelerating innovations in 6G. Please welcome Mr. Rajesh Kumar Pathak. Over to you, sir.
Yeah, thank you, Asta. And I would like to even thanks Mr. Ashok Kumar our colleague. So I will be just discussing what is this Bharat 6G alliance means, because I think there is some confusion. Why Bharat 6G alliance should be there? And since 6G would be, one can say IMT 2030 has already been explained by my previous speaker, so I won't be, I think, giving much, speaking much on the subject. This Bharat 6G alliance has a vision that when 6G will come, then it has to be affordable, sustainable, and ubiquitous. Once India says it's affordable or even ubiquitous, I think it has the different meaning altogether. Because once we say affordable means somewhere below $10. I mean, the service, whenever you provide, it should not be more than the $10. And ubiquitous means how we can bring the space and terrestrial integration. So these are the some of the keys I have taken from the Bharat 6G mission of Government of India, and we will be working along with academia, industry, startups, because they are, I think, main force behind us. That once something is developed by the academia, how can we make them the product, and not only do our innovations for the India, but we have to work for the world. So these are the broad objective of Bharat 6G mission. It is mentioned there that it will be done in phases. So phase one will be like right now we are going exploratory, when we'll be inviting proposals, working on that, learning something. Even we can change the course correction as well. And there are certain actions has been taken by the different wings of the government. I'll be just sharing those as well. So Bharat 6G Alliance is a public-private consisting of public-private companies, academia, research institutions like CDOT, CDAC, or even private institutions, and standard development organizations like we are working with across the world, but in India, TSDSI is one of them. So these are the certain mandate given by the Department of Telecommunications to Bharat 6G Alliance. So our mission, our vision will be how to realize the 6G vision document of Government of India, which was unveiled by our Honorable Prime Minister on 22nd March, about more than a year. But Bharat 6G Alliance was launched on the 3rd of July by Honorable Minister. So I think we have just completed 1 year, and that's why we are started this series. So we are open for working with the like-minded global collaborations, and we don't want to reinvent any field, and we don't want to develop any technology for a particular country or geography. But I think we have to work for the entire world. So I think we have to be open for the collaborations. This is a structure one can understand that at Department of Telecommunication there is a 6G Apex Council headed by Honorable Minister, and Bharat 6G Alliance, whatever is the output of Bharat 6G Alliance, that will go to Department of Telecommunication and 6G Apex Council. We have a working group presently. However, there is a provision in MOA which is available on our website that there will be expert committees. We will be working with the coalition partners like NextG Alliance and other within the India also, like even BIF is our member and others, and working with academia, industry, startups, getting these inputs and bringing to this working group, expert group, and governing council level, which will be finally going to Department of Telecommunications. These are the various other departments, and they are presently part of our governing council. They are government nominees. So we have government nominee from Department of Telecommunication, Wireless Planning Coordination WPC, TEC, MIT, Department of Science and Technology, Department of Space, Ministry of Railways, defense and home affairs. What is important that in this process of development of or innovation of 6G technologies, we know that 6G is dependent on a number of other uh, departments as well and use cases. So we have a lot of learnings from 5G, and then I think we have to work on all the use cases along with the development of 6G and allied or related technologies. So that's why these are the ministry department. They are on our governing council to guide us, give the directions, their regulatory directions, policy directions, in which directions we have to work. But we will be just approaching as a part of our exercise to entire government, all the industries, including hyperscalers and other manufacturers and other service providers, satellite providers. They are the seven working groups. Spectrum, we have already Spectrum task force reports available on website. Device technology also, which was headed by Professor Kiran Kuchi. I think he will be speaking, he will giving insight after some time. And technology by Professor Bhaskar Ramamurthy, applications by Amritur Bhardwaj. Green and sustainability outreach, and more important is that we realize, and when I think visited some other events, etc., all we are saying that why a operator is going to invest in 6G. So can there be some use cases and revenue stream? It means we have to work from the very beginning on the development of 6G use cases and some revenue stream or such applications that even operators get revenue out of our uh, 6G applications. Then only I think, and these are the various technology like extreme massive MIMO to the HAPS, LEO, MEO, and distributed intelligence in networks. We have to work on all, and I think that was shared very nicely by my previous speaker, Mr. Ashok Kumarji. So I don't want to say the technology part because I think that's it. We can expand it also once you join us in this process. These are the various other technological one can say that we have to work on even dense integrated optical sub terahertz and terahertz integrated terrestrial and non-terrestrial integration. So these are the various technologies which we have to enable as a part of India. It will be possible that something will be working for others, and these are the various focus on standard contributions where I think we will be going through our TSDSI, if that is research based, depending upon the SDO, a forum, global forum, will be going through it. Telecom Engineering Center, which is the government itself. So whatever is done, so they are the ultimate authority. But even we have to go to BIS. We are open for going to BIS. Same way we can go to ITU, APT, IEC in this process. And these are the some of the priorities area we have indicated. But more important is that how can we use the technology for rural areas for solving our problems of connectivity, our education, our health in rural areas, for making India a digital nation, a digital economy. So I think right, presently we are just doing traditional, something like Delta. I think complete change will be required. And so many can we do some innovations that let's do innovations from India and take it to the world because I think still there is a lot of opportunity for us to work together with others and there is no killer applications even in 5G. These are certain R&D funds available with the government, and the first one is the by Department of Telecommunications. We have more than 100 million per annum under TTDF, DCSIS, or even CDOT funding scheme. Under that scheme itself, we have set up already 6G test beds and 100 use case labs for 5G and beyond at institutions. I am sure that this will create a ecosystem within the country for R&D, and when we have to uh, bring startups, MSMEs, big companies with academia to work together. Same way to quantum technology, we have the quantum national quantum mission. Department of Telecommunications will be more focusing on quantum communications part, and they will also be getting funding from this quantum national quantum mission from DST. Even DST has another very interesting national mission, that is interdisciplinary cyber physical systems. Presently, Triple IT Bangalore, they have developed, I think, first ORAN utilizing this fund. But these all 25 institutions are important for us once we say 6G, because 6G will be in all the 25 domains and nothing to do with just communications. So I'm working closely with the DST also to convince these 25 institutions that there is a lot of opportunity. How can we work from the very beginning? Initially, it can be 5G, 5G advanced, and then actually 6G. Indian chipset mission, we are aware that there is a 10 billion fund available, and actually India AI mission, where is also again about 1 billion fund, more than that is available. So how can you utilize this funding, working together, writing white papers, influencing the decision making process, that we get our shares and develop the technology, our innovations, and even contribute to standard development organization, that is very much important, and do commercialization. So all will be important for us to take it, and these are the various already approved schemes like accelerated research on 6G ecosystem. There is a proposal by Department of Telecommunications. I am sure that a lot of you joined here might have applied. There are more than 470 proposals, and they are in the process of evaluation. And I'm sure that this will create IPRs. Because there is a target by Honorable Prime Minister of creating more than 10,000 IPRs in 6G and one-sixth contributions from India. Under CDOT, they have their CDOT itself, they are doing in the entire development ecosystem. However, they have a CDOT collaborative research program under which they have funded open RAN consortium projects, as well as a number of other projects are going on. So we can utilize even CDOT collaborative research program itself. 6G end-to-end communication system was funded by MITI, and same with Extreme MIMO testbed. Again, advanced communications, optical communication testbed, and others have been funded under TTDM scheme. I am sure that these fundings, which have been done at led by IIT Madras, Samir, IIT Roorkee, and other institutions, will be utilizing for our benefits. And whenever government funds, it's for not for a specific institutions, but others can also join, including the startups. Department of Telecommunications is presently working on digital twin for national infra optimization, and they are going from the in the stage one to stage two. So I'm sure that digital twin also create lot of opportunities for us to work together. And in this process, we'll be leveraging academia, startups, and all ecosystem players, as I told, that even satellite hyperscalers, etc. I was referring to the global alliances in 6G development. So already we have with the NextG Alliance of USA, 6G Smart Networks and Services of European Council, and 6G flagship University of Oulu, Finland. We are already, once we say we means Bharat 6G Alliance here, we are already under the active discussion with 6G forums of South Korea, XG Mobile Promotion Forum of Japan, and Next Generation Mobile Networks (NGMN) of Europe, that is a TSPs, and others have also they have given their draft, and they are very eager that how can we work with Indian academia, startups, other ecosystem, because they have also facing the same problem that they have developed certain technologies but they are unable to do pilots. So how can utilize these international collaborations for our benefits? That I think we have to think through. These are the various just snapshots. Bharat 6G alliances, others internationals have also joined, and I'm sure that it will be a process going on. Once it comes, why you become the Bharat 6G alliance member? So once you contribute at technical working groups or you contribute in white papers, so you can not only influence various department in the Department of Telecommunication, DST, MIT, or even education others, but uh, it will be global. That what is the thought process of India? It will be in the form of short term, long term, and how we can you once you develop the technology, how can we assist Bharat Security Alliance you doing the pilots. It can be within the country uh, and even outside country with our partners. How can we generate IPRs and develop technology which is more suitable for India? But as I told that we have to think always global, that how can we take our contributions to global platforms, sell our equipment. It's possible that why don't you first do our pilots in other countries as well. And naturally, we'll be in this process or in consortium approach, we'll be working with other partners across the world. And once you also come together, all the academia, because I realize that even one is not aware of others. So this will serve as a platform. So I'm just inviting you to come on the Bharat 6G Alliance, and all the details are given on our website, bharat6galliance.com. This is what I think I have to share from my side. I'll be just giving back to, yeah. So back to Astha. Can you just take over?
Yes, sir. Thank you, sir, for such an insightful presentation. And we are really getting good participation and appreciation from the participants. Probably they have a lot of queries and they are appreciating the presentations presented by you. So a lot of exciting stuff being presented by you on the through your slides. Now, moving ahead, we have the panel discussion on the topic The Future of Connectivity, India's Roadmap to 6G. And we are really honored to have with us distinguished speakers for the panel discussion Professor Kiran Kochi, Vizag Networks Private Limited, Professor R.K. Ganti from IIT Madras, and Mr. Jishnu A. from Tejas Networks. The moderator for the session would be Mr. Rajesh Kumar Pathak. Before starting the panel discussion, I would request if Kiran Kochi sir, we can wait for him to join the session.
I think Mr. Kiran is yet to join.
Okay.
He's yet to join. So I think we can start
Okay,
with.
so before starting the panel discussion, I would like to provide a short bio of each of the panelists so that our participants be aware about. So first of our panelists is Professor Radha Krishna Kanti, who is professor at IIT Madras, Chennai. He received his BTech and MTech in electrical engineering from IIT Madras and a master's in applied mathematics and a PhD in electrical engineering from the University of Notre Dame in 2009. His doctoral work was focused on spatial analysis of interference networks using tools from stochastic geometry. And he has lot of accolades with him. He has received lot of prizes, which is displayed on the screen. So, without ado time, I would also like to inform about the next panelist, that is Mr. Jishnu A, who is the principal architect technologist in the CTO's office at Tejas Networks. And he brings with him 20 years of exemplary experience in the telecom industry. A graduate of NIT Calicut with a BTech in Electronics and Communication and a master's degree from IISc Bangalore, Jishnu has been instrumental in shaping the long-term roadmap for Tejas Networks. And to him also, he has provided notable contributions representing Tejas at various ITU platforms. And he has filed 16 patents and received numerous accolades as presented in his slide, Best Paper Award. So before not taking so much of time, I would hand over the discussion to Rajesh Kumar Patak sir for the moderating the session. Thank you, sir. We welcome each panelist. Thank you, everyone.
Thank you. So still, I think I'm just waiting for Mr. Kiran. So let me start with the first, I think, Mr. Radhakrishnan Ganti, because I think he has been championing us from the 5G I. and we have lot of some at least 10 years experience, and that will be something a lesson for others also who are just part today joined, that how India can be innovator. Earlier we were not even allowed to sit on the table. So I'm sure, sir. So I think this is my thought process on 6G, that during the ITU minimum technical performance, there was a debate on AI for network or network for AI. That is the first. And then how best can we capture the AI capabilities in minimum technical performance report. Other than that, you can just speak whatever you want for 5 to 10 minutes. I am giving floor first to you. Over to you, Mr. Radhakrishnan Gandhi. Welcome.
Thank you, sir. Hope I'm audible.
Yes.
Yes. Okay. So, thanks for giving me this opportunity to be part of this panel. So, before I get into the AI part, I want to talk a little bit about the 5G journey and how what is happening in the 6G world, also with respect to what we are doing as a country. The previous speakers, Ashok sir and Patak sir, have already mentioned a little bit, but I'm going to add a little bit to that. So when we started the 5G work, things were a little bit sporadic. I mean, the few of us, either in DOT or academics or industry, mainly based on personal interest, that we would have been following this whole gamma game. So when we went to ITU for the LMLC and other things, our delegation used to be like one or two people trying to fight out a lot of things. But during the course of the journey, there was a lot of support from the government. I mean, all of us learned from each other on what needs to be done to actually deploy technology and to be leaders in a technology. Okay, it is just not a one person's game or two person's game. A lot of ecosystem has to be built. A lot of you are involved in industry, and all of you understand this. Okay? That is precisely what the government is doing for 6G. So to actually get to be leaders in a technology like 6G, a lot of things have to happen simultaneously. It's not like one thing, you wait for one thing to happen and the next thing to start. So, for example, technology development has to happen. So, I mean, we are in the game only if we own the technology. It's not like we implement the technology and we become masters of 6G. That's not going to happen. So across institutions, academic institution, and research organization, various research organizations, a lot of work is going on the further future technologies of 6G. For example, terahertz, there's a lot of work going on. Full duplex, there's a lot of work going on. AML, there's a lot of work going on the core network, optical networks. So a lot of these things have been fun. I mean, in the previous speaker, I mean, Patak sir has already pointed those. So a lot of work. Government is funding a lot of these things so that we are in the forefront of technology development. And I think that's the correct way of doing things. And I'm hoping that we are focusing on all the required technologies. Okay. So the next part or pillar of this game is standards. Okay. So technology development is one thing. Taking this, whatever technologies that we have developed into standards is also extremely important. Otherwise, it will just be on paper, and it will become more of an academic pursuit, which is also not bad. But I think, from as a country, we should see how to convert our technology to standards. And towards this, again, there's a lot of push from the government and industry also. Okay, so now, I mean. To prove this point, I mean, Jishnu and Professor Kiran have been leading the efforts on the ubiquitous connectivity in ITU. And I have gone to ITU recently after a long time. And what I see now is a very, very stark difference from what we have seen in 5G. I think we're actually leading the whole discussions. You know, as a country, we are leading the whole discussions, which is surprise. I mean, which we couldn't have believed a few years back. We are setting the tone on many of the things, KPIs that Ashok sir has decided. We are setting the tone, and we have like substantial, huge power to be reckoned with. Okay, that's very good. So, but this has to increase. To do standards, we have to all file patents. A lot of patents have to be filed. We have to start doing 3GPP. All this has to be coordinated. Again, there's a huge coordination effort going on from the government, but I think more needs to be done on this regard. The third pillar is the test beds and prototyping. So before anything becomes successful, or we can go to 3GPP and say that this is what has to be done. We require to prototype those ideas. We require to build ourselves the complete 6G even before we go and say that, hey, 3GPP, this is what we should do. We should have a fair idea. By that time we go to 3GPP in the next 3 years, we should have built everything. We should know this is what India wants to do in whatever technology it is. And that is the prototyping of test beds. Again, other institutes, the DOT, MIT. A lot of money is being put on this test beds, and I think we are doing good in that. But I think more people to start participating on this. The other most and has to come into place is the policy. While all these things have an influence, finally spectrum is what is going to get all. Government knows this, and they are working on this on what are the new bands that are going to be released, and this is where alliances with other countries are going to make an important role. And this also opens up opportunity to both academic and product development companies to understand what spectrum is going to be released and what they want. IoT, what is a good spectrum? So we have to start discussions with the government and push it to other ITU level for this. And the most important thing is the final overall. Okay, so I have told you about four things. This cannot operate independent of each other. Okay, and we require an overall group who looks from the top down and says, this is what is missing, this is what has to happen. So we require a pyramid kind of an architecture where there's someone pushing down things that this is where we have to head and this has to be gone. It's important. The DOT should come together and understand how do we coordinate across all these things in a more efficient manner. Okay, so I'll just take a couple of minutes on the AI for network and network for AI. Sir, I hope that's okay. One of the main things, one of the main use cases is AI. AI for IMT 2030. The question is, there are two parts of AI. One is how does the 6G network support AI applications? Okay, so this is what is called as a network for AI. And the other thing is, how can AI be used to improve 6G communication itself? Okay, so they're two separate things. I mean, at least from a high level, they're two separate things. So one of the questions that is coming, so we want to quantify how AI will improve both these things. How network will improve your AI and how AI will improve your network. Okay. So how do we quantify these things? What are the metrics that are there to quantify? So as part of, essentially, we can come up with a few metrics for this. So for example, I mean, we can understand how much latency does your network support for AI kind of applications. Okay, suppose you want to download a model. Okay, are there any special API that is given by the network to download a model or update a model? If you wanted to distribute AI, how does your network support it? But see, we are in the process of thinking. I mean, so this is what is going to happen in the next few meetings, and the input contributions are being looked at. So how do we come up with quantitative metrics? Is it even possible? For the first question which I ask is it even possible to quantify on both these accounts, AI network and network via specific metrics that we can evaluate for the candidate technologies? That's the first question to ask. If yes, then what are those metrics? I mean, they can't be some metrics which we cannot evaluate or very theoretical metrics. There should be metrics that I can evaluate. I mean, groups can evaluate on the proposed technologies. Okay, so it's a very, very tough thing. This is where I believe that contributions from all the people would be very, very important. On the other thing, also we have also start looking at how networks should be designed from an AI perspective. So if there are startup companies or companies who are working on this area, it would be important right now to start discussions with both DOT and all of us, so that we can take these specific requirements to ITU and say, hey, these are the specific API that we require from to support AI on the network. Our high level things, we can take parts of that and put it in this documents. Okay, so this is where we are, and there's a lot of interesting work going on network on AI for 6G. AI for 6G and 6G for AI, both of these things. And so that's all from my side, sir. Thank you.
Thank you. I'm sure that Professor Kiran, I'm requesting him that he should make his video available. Professor Kiran?
Yes, sir. Sorry, I joined late. Yeah, please.
No
Yeah,
issue. I realize that you are not well, but let
yeah,
me
yeah.
welcome you. You have been the torch bearer of technologies. So, five or six, we can say anything. So, this Professor Kiran Kuchi holds a position as a professor. I think each one is knowing, so I don't want to say. But if you say 5G, I are so many NB-IoT, etc., he has done. So, I am sure that let us hear him because he has been the professor at IIT Hyderabad. But more important is that he's an entrepreneur as well, and he has already developed under the YSIG. So, sir, now you can share all. I think it's important, but a lot of academia is here. They are thinking that how can they contribute, and they ask even questions to me. Sometimes I say that it's academia to, in fact, teach me why they should join and why we all should come together. But I think as you let the technical, let us know the key contributions of India in ITUR, and that is M21601, it's 6G IMT 2030. I met NGMN, not GSMA. Both were saying that it's release 21, it's not 6G. So, I mean, you call by any name, but how can we make India a technology leader? So, that is our one liner that we have not done anything in 2G, 3G, 4G. In 5G, we have started our journey. We are, I think, fifth country to have developed 4G now by Tejas and CDOT, TCS as a leader. So, how can we be a technology provider from India in 6G and related technology? It's nothing to do with just technology. So, over to you, Professor Kiran.
Yeah, thank you, Pathak ji. So, I think we can take a leaf out of China's book. When I remember that when I was contributing to standardization many years ago, I think it was around 2000, 1998 to 2000 time frame. 3G was being standardized. I used to do some work. That was when I was in the US. I remember that both China and Korea, they were in a very early stage. I used to read their contributions when they submit, to standards. They used to be, very early days. I could see that. But fast forward 25 years, look at where they are. Especially China, they have really progressed tremendously. So the reason I'm referring to this is that the Chinese universities, they have grown by leaps and bounds. I spoke to a lot of people in China some years ago, how they do things. So this is something I think I never mentioned to anybody. This is probably known to a lot of people. Chinese government gives a lot of grants to universities, all kinds of different universities, and lots of companies came out of Chinese universities. Okay, they take these grants, the professors use their students, they build companies, especially test and measurement companies. A lot of them, local companies in China, they came from Chinese universities, and the rules that are required to build companies, they're very liberal. That is actually also true in India. I don't know if many of you know, the policies, the, that are very friendly to starting companies by professors. There is an MHRD guideline given to various universities and IITs and the various universities. In fact, when I was the dean, I converted this policy on how to enable faculty and students to start companies. I codified this into a full-blown policy approved by my BOG some few years ago. This is very friendly. I mean, you can do a lot of stuff. Indian universities allow that. Maybe the rules vary from university to university. So the bottom line is, government should fund very liberally to universities, whoever they are, and let the university incubator allow this technology to be commercialized. This is point number one. But if you just give money and then say that, okay, you do something, what will the professor do? The professor should actually not only develop themselves, but also work with industry, whoever they could find. Go there, spend time, work year, 2 year, sabbaticals, go to standards meetings, talk to people. It's a long journey. It's not going to happen in 6 months or 1 year. So there are two critical ingredients. You have to go work in a company, whoever that company. Maybe there are 5 or 10 companies doing wireless communication products in India now in different forms. You can collaborate with them. You can work with them. So you have to come out of the comfort zone and do this. China has been very successful in terms of bringing professors and universities into this fold. So that is one suggestion I have to people who, if they are really interested in doing something. And of course, as Bharat 6G Alliance, we should let this funding to be given to tier 1, 2, 3 universities. Yeah, that's my first point. Yes, yeah. So you can ask me other questions. I can go point by point. Yes.
No, let me then just I think come to Mr. Jisnu also. So he represent industry part. So let me his I think he would like to go by first the what is the connectivity safety parts. So over to you, Mr. Jisnu.
Thank you, Pathakji, and thank you for inviting me in the talk. So I will just start this presentation from where Ashok Kumar sir left. So maybe if we can go to the next slide.
I have made you presenter also, so you can perhaps
Yeah, okay.
change your slides.
Thank you, sir. Yeah. So as mentioned by Ashok Kumar sir, so there is now a set of usage scenarios which has been finalized, and as mentioned by Ashok Kumar sir, the ubiquitous connectivity was something driven from India, and we also drove some of those capabilities, whether it is coverage, sustainability, and interoperability. So these are all part of what is now called the M.2160, which is the framework document for 6G. What we are working today is to map this usage scenario with a minimum TPR to all these capabilities. So each usage scenario would in turn have a certain set of capabilities, and each of them would have certain values to be met, which can be evaluated either through analytical, simulation, or through inspection. So these are the three ways to do the study. And as Professor Radha mentioned, that for AI, this is still under discussion on what are the actual way to sort of measure it. Do we do inspection or do simulation or do analytical research? Few of these are already finalized. For example, peak throughput is always through analytical mechanism, and that may be needed not for everything. So, for example, ubiquitous connectivity may not be needing what is called a peak throughput. What we would be needing is what is called a user experience data rate, a coverage, which was also mentioned by Ashok Kumar sir. So these are some capabilities which each of the usage scenario would need. So all capabilities would not be met by all the usage scenario because it's not relevant. And then this then in turn triggers multiple technologies which would have to meet those usage scenarios and show that they meet the capabilities either through analytical simulation or through inspection. So these are the three ways it would be evaluated in ITU. Uh, After that, what happens is every SDO, Standard Development Organization, can develop their own standard. So, for example, if I take 3GPP, they are planning to start this work around 2025, where they will do the stage 2 work of release 20. And then you would have phases where initially it starts with a study item phase, which is shown in the pink color at the bottom, and then follow it up with a work item phase. In the study item phase, they would discuss multiple options to develop, meet those capabilities or usage scenario. And then in work item, take concretely some of them and proceed it into standardization part. After this, okay, so specifically coming to from an India point of view, what we see here, so this is specifically a Tejas Networks point of view, is that India has been in the forefront of driving connectivity everywhere to each villages, and now even from the effort of government, they are taking it to each household in the villages. So this is an area which India has to drive, just because India has 60% of population in rural area. Unlike many of the developed countries, where the population ratio is only 20% in rural areas compared to 80% in cities. So even this here we would have to then define our own test environment, which is earlier in case of 5G, Professor Radha and Kiran were involved in defining what was called an LMLC test environment, which was specifically based on some measurement done in Madurai in Tamil Nadu. So similarly, we can define more of those test cases, which is whether it is for ubiquitous connectivity. It is almost clear in India that you can't take fiber everywhere or even take terrestrial network everywhere. So you would have to have HAPS, even NTN, which is in the NTN HAPS, and even satellites. So how do you bring all of this to meet what is TRAI's recommendation of broadband, which is basically 2 Mbps data rate for everyone, wherever it be in the country, which is what is the TRAI's goal and as well as the government of India goal. So how do you map this? Say, for example, we could put user experience data rate as 2 Mbps. Do we meet this today? No. For example, in Bangalore, uplink throughput, I can get 2 Mbps in Electronic City where I am there. Just walk few kilometers away, which is a small village here, it comes down to zero point 0.3 Mbps. Okay, so these are all published in, if you, there is a website by Try, you can go there and see what is the peak data rate we get for whether it's downlink or uplink. So few of this can be codified as a minimum TPR, and hence the work can start on each of this. There are multiple technologies. Say, for example, IAB is something which Professor Kiran has been working on, or RIS is some technology which IIT Madras, IIT Hyderabad, many other IITs are involved. NTN is some work for different layer. There are different startups working on it, whether it's UAV based, HAPS based. So these are completely new field which can provide connectivity, but we could put a minimum TPR, and some of the work may happen in WP5D. WP5D deals with only terrestrial. So here we have restricted it only to the terrestrial problem of ubiquitous connectivity, which is to increase the uplink throughput by improving the coverage. So that is something which will drive in WP5D. There are other ITU bodies like WP4B, 4C, etc., which are driving aspects which are on satellite. HAPS, which is a new field, is in a gray area. So maybe it's a terrestrial or a satellite. So these are something which is being work happening in different standards body. And even in, for example, RIS is a standard which was recently approved in TSDSI, maybe the first 6G standard to come out of anywhere in the world. The initial architecture documents are finalized. The other things have to be worked out, whether it is the protocols, etc. So TSDSA also provides some forum where you could work on the integrities of this standard. So all this SDO then provide this input to ITU, which would then evaluate this and figure out whether it meets or does not meet. So in 5G, for example, there were only two guys initially meeting it. One was from 3GPP, another from TSDSI. Later, I think ETSI's DECT met this. China is still struggling to get their new friend technology approved as an IMT 2020 technology. So there are different efforts, and we were much ahead in 5G, and hopefully in 6G, maybe we can even beat them in this game. So that concludes my talk, and maybe over to Pathak ji on the questions.
Thank you. So I think we are, I think, ahead of the curve for 6G technology. So I have a question that this is for all the three panelists, starting with you. That what key 6G technology should we focus on to meet minimum technical performance report (TPR)? So first, I think Jisnu, then I think Radha, and then Kiran.
For from an industry point of view, we are looking at seeing how we can use AML in air interface and in slicing. So this is one aspect which we are looking as a company. The second thing is that we are seeing how do we model channels for ISAC, integrated sensing and communication. Other things which are specifically of interest for us as a company is network energy saving. So this is something which has happened in 5G, and it's a continuing work. So if you see one of the parameters which was never met from a minimum TPR perspective in 5G was NES, network energy saving aspect of it, which is something which is very important from an operator point of view, because it's key to make a product successful in the market, because finally the operators have to be successful for any technology to really succeed. For them, the key problem is how do you meet, how, do you, how are you profitable even at an ARPU level of $3, which is what we have in India, which is something no other country in the world has it. So this is such a tremendously different aspect which we need to look into. The other thing which we are looking in are things which are, I think Radha has been working on this for quite some time, which is full duplex. There is a what do you call as version of it called SBFD, which allows you to improve coverage as well as reduce the latency. So that is some work which is started in 5G, but I'm sure it will become full in-band, full duplex by 6G. The other aspects which work is happening is about batteryless devices, which are comes under in 3GPP terminology called ambient IoT. So these are some activity which we are looking at in from an industry perspective, which would eventually become a full-blown technology in 6G. But other things like terahertz communication, for example, is interesting from a backhaul perspective. Industry is not looking into it, and I see a lot of work happening in academia on that. And if we see that becoming a good option for a backhaul, because initial studies by NTT Docomo shows that we can get up to 100 meter, which is a decent number. But initial numbers were around 100 feet, which is not so promising that way. So it will depend on how terahertz research happens in industry, in academia, and if it is promising from an industry point of view, we would take it up and implement it in applications which we find it useful there. Something similar is happening in FR2, for example, in that same spectrum. There are other things which are happening which are new waveforms. So, for example, first time in 3GPP, LP WUS has added a new waveform in addition to OFDM. They have added some OOK plus OFDM as a mechanism to wake up the device to save power, etc. So these are something which are possibility of research. How do you have a new waveform added into 6G without sort of affecting the backward compatibility, because we would still have to run devices which may be a mix of 4G, 5G, and 6G. So these are all interesting fields of research, and few of them has straight away commercial applications which we have picked up. Things like terahertz, etc. We are waiting for academic research to show the advantage of it. In addition, there are research happening on optical, not just on the wireless interfaces. I think it is led again from IIT Madras. Professor Deepa takes care of that part of it, which is how do you backhaul it through fiber? Because if you are having such high throughput on the radio interface, you need to backhaul this through fiber. Is there some better way to do it? Can I do what is called a radio over fiber rather than the present mechanism of carrying it as a digital signal, etc. So these are other research which are happening in industry, in academia, which is also of interest for industry. Thank you, Pathakji. Over to you.
Thank you. So I think Radha, what's your view?
Thanks, sir. I think Jishnu did a pretty overhaul, comprehensive view of what is the research required, but I'm going to add a little bit to that. So I believe one of the things that we should focus on if we really want to become leaders in this is massive MIMO and the extreme massive MIMO. What is happening in real field, while 5G also had massive MIMO with large number of antennas, what at least stands that the performance, there are lots of gaps, and also understanding of this technology is also not very mature. I think it's a right time for us to start putting together this massive MIMO and extreme massive MIMO solutions, because in 6G people are talking about a few thousand antennas. So from both academic perspective and industry perspective, how do you build such kind of monstrous devices? We have to start looking at this. Lots of interesting research problems there. The second thing is AI/ML. I think a lot of focus should go on AI/ML also. One is, of course, how do you use, what are the properties of the network that we require to do AI/ML effectively? I think that's still a large open area of research that's pending. I don't think anyone is working on that. That's a very good area to work. And the second thing is, of course, a lot of people are working on how do you use AI/ML for enhancing the performance of networks. Still a lot more work has to be done on this area. Specifically, the problem is largely on the data sets. How do you acquire data sets in this kind of AI/ML? So that gap has to be closed. I believe that newer waveforms, see, essentially when we go to terahertz or even millimeter wave, one of the problems people faced in millimeter wave also in the previous generation was the waveform was not the correct waveform. So you are not getting power, it was absorbing a lot more power than required. So I think waveform research is also important. I mean, I think OFDM is going to stay, but I think other waveforms are also going to make their presence felt in 6G, at least to a certain extent in newer frequency bands and other specific use cases. I think there's a lot of work pending there. IoT. 5G promised a lot on IoT, but has completely under-delivered. This is because IoT, as part of a cellular system, is there are gaps in terms of power consumption that is there, the complexity of the device. I think a lot more work has to be done in that particular area, and hopefully we can come up with better architectures in for 6. That's all I have to add. Thanks.
So I think you have shared since a lot of academia, industry, even tier two, tier three are attending. So that these are the I think some of the thoughts. Now let us hear Professor Kiran itself, who is working and championing NB IoT. I am sure that how can we do much things in India for the world.
Yeah, thank you, Pathakji. I'll first address the expansion of 5G into 6G. Then I'll talk about IoT. So there are two views emerging. One is especially in the meeting in Glasgow, we both myself and Radhakrishna were there. The 6G alliances and others. How do you leverage 5G and then move to 6G by not making a wholesale disruption? That's a very tricky question because if those of you who are familiar with the cellular systems, there are two boxes that are used in the network to serve 5G. One is a distribution unit that is under the tower. It's a baseband unit. There is fiber, and then there is a radio unit. And the radio unit is highly a function of carrier frequency. So when you say we are moving to 5G, fundamentally you are going to add a new band. If you don't add a new frequency band, when you say move to 6G, you add a new frequency band. If you don't add a band, I mean, there's no point in having this discussion altogether. So when you add a frequency band, you can't say that we'll just use the same radio unit as is. It's not programmable to support, let's say, 7 gigahertz or 8 gigahertz. They're not designed like that. But a large chunk of software inside it may be reusable, but you have to build new equipment. So new radio units have to be built if you move to 6G. This is inevitable. That means there's got to be a standard. There is room for changes in how the radio unit is built. You can put 1,000 antennas. You can put all kinds of different things in the radio unit. Now the specification or the standard that deals with, let us say, the signal flow on the protocols, do they have to change? The answer is yes and no. The 5G new radio system has enough room to be able to migrate to a new frequency band, maybe using release 18. This is one kind of view. Okay, so use release 18 of 3GPP. It already supports thousands of antenna elements and maybe 128 ports and things like that, and then use it as is. This is probably one way to do it. But anyway, release 18 is not deployed, so it is also 6G in some sense. So this push and pull will be there. How much of the existing standard you will change, or maybe you make these changes so that they're all software implementable. For example, if you change a waveform which you can implement in DSP software, it makes hardly any difference. As long as the chipset is reused in the baseband side. So so the crux of the matter is reusing the existing chipsets. That is either in the DU or in the RU. How much of it will you reuse? And how much of it will you upgrade to accommodate new frequency band? This will be an interesting discussion as companies really try to leverage the hardware, software, and how much of new work you want to do. So we'll see. Now we have some solutions that can be introduced through a software modification by modifying OFDM and really get a lot more out of the radio especially when you move to new frequency bands, whether it is 7 gigahertz, 13 gigahertz, and so on and so forth. But as far as India is concerned, I think 6.425 to 7.125 is a band that we should seriously look at. You can get a performance, if not equal to existing 5G mid band, but we can get somewhere closer to that. We can't be sure whether the signals will go inside the buildings and people can connect. So this throws up a very interesting research problem, which we have to tackle head on right now. How do you use frequencies above 6 gigahertz? Can you create a radio access network out of it, or is it only limited to backhaul? So that brings the notion of integrated access and backhaul. Are we going to limit these frequencies only outside the home? Connect them through poles and create all kinds of meshes, backhauls, or are we going to serve people, and indoors with these frequencies? This we should start the work right away. Put a lot of investment into it, and we don't have a whole lot of time. We have to do it within the next 12 months. I'll stop here. Thank you.
Thank you. I request all the panelists to just see the public chat also. Okay, I think people have started uh, making their questions here. And I just realized that even perhaps Professor Kiran has answered a question by Mr. Aspas Singhal. He represents NGMN. NGMN. And his question was that radio interface for 6G, want to know views on radio interface for 6G. Are we really expecting to have essential RRH antenna change? Perhaps I think you might have covered. If not, then I think we have to see here that if you have some interesting questions, then whoever is the expert on the subject, because I have industry, Mr. Jisnu, Professor Kiran, who is a startup as well as professor, and Radha, I think a pure technology developer. So we can just see some questions are here also. In addition, I think I would like to know that what's the various activities happening in academia, because there is one question also on where 6G testbed is being set up. If I remember correctly, that's led by Samir, and optical was done led by IIT Madras, and I think there are other projects also with something happening at IIT Roorkee and some under TTDF. So I'm sure that I may not be competent to speak on behalf of DOT, but academia definitely, if you have some information, please give those information here.
Yeah.
And just see the chat. Yeah.
So there are a few questions on challenges in terahertz band. Okay, so the terahertz is by Samir with other institutions involved. So it's in Samir. So what are the challenges in terahertz? This is a very, very high frequency. Okay, so the propagation is extremely difficult. And the other major difficulty in this band is getting devices. Okay, so the device ecosystem in this band is very not mature at all. Getting power amplifiers even at 0 dBm or even 10, not 0 dBm, but 7, 10 dBm is very difficult. Work to develop transceivers in this band so that basically over 100 is possible is what people are looking at. So one thing you should realize is while terahertz may not become an access technology, it can certainly be used as backhaul technology, as an interconnect technology, which is very useful, which will be a good replacement for the current RF backhauls because of the limited bandwidth that is there in the RF current spectrum. Okay, so that is these are the limitations of the terahertz. So there are other questions, sir. Maybe other panelists can also. Please.
Yeah, I'll just add to what are the limitation of RF backhaul. See, right now in the last mile, quite a bit of things are done on microwave backhaul, which are uses similar frequencies as what we are discussing for 6G, whether it's 7 gigahertz or 13 gigahertz. So now the question that can be straight away asked on RF backhaul is, can I use that as a frequency for backhaul where everything is standardized? Right now, if you see microwave backhaul, there is nothing standard. It's all book-ended solution. Both ends has to be from a same vendor. and they use proprietary waveform. So can something be different there? So that is one aspect of it. The other thing with issue with RF itself is that it's not very reliable. So if you have to improve reliability, and we are trying to improve reliability quite a bit in 6G, you not just the radio interface has to be reliable, because from a user perspective, so those reliability can go up if you have an optical backhaul with some redundancy built into it. So there are effort in India also to build redundant microwave links. There are P2MP links which are built up with redundancy. So these are some things which would need to work out in RF also, because we are using higher frequency. There are limitations which comes up with oxygen peaks and other issues related to the bands which are there, which comes up. So generally there is a preference to do optical backhaul, and that sort of allows you to also have a longer backhaul, which is another issue which comes up with RF. The backhaul links cannot be much longer. So these are few things which are there on the RF backhaul part of it. So maybe other thing Kiran can explain the other question.
Would you like to say something, because there are questions related to you as well?
Pathak, this question is about the RF upgrade in the radio unit. Is that what I think that's what Mr. Shashok was asking? How do you upgrade the radio unit? Is that what it is?
You just see public chat. It says that request for Professor Kiran Kuchi sir to focus on NB IoT chipset module and its
Okay.
communication. I don't know what you mean by that, but I think you can just.
Yeah. Well, I can. We this is one unique project that was funded by DOT in 2018 time frame. We started this activity of building a full chipset. It took us quite a bit of an effort, because it's the first time a cellular modem, 3GPP class of modem is being done, and it has a GPS built in. It has a narrowband IoT modem, and it has to have a low power consumption. It's highly integrated modem. So, in fact, we have added also a satellite communication band to it, L band, so we can use the same chipset to connect to geo constellations with software modification. So it acts as both terrestrial and non-terrestrial modem. Now today we have the chip in a form that we are doing GCF testing. This GCF testing is like when you enter the market, you have to pass certain test cases. So the chip is fully functional, and we are doing GCF testing. So the plan is end of this year we'll have our own modules. We can call them test modules. The chip is one thing and the module is something else. We are just going to come up with some modules to do outdoor testing with operator networks. We are completing the GCF testing right now. The plan is to have volume production in place next year. This is the TSMC 40 nanometer node. So you will likely see a full production chain running more like at the end of next year. We will be producing the chips. So we are also trying to get some volume orders. That's the harder part in any chip business, but we'll line that up. So in a nutshell, NB-IoT terrestrial and non-terrestrial is in place. We can cater to both cellular and geo satcom. We're also working with ISRO on the satcom part, doing some custom communication systems using the same chip. It's fully software defined. But the one thing that the learning that can come out of this exercise is that we can actually indeed build a cellular class of complex chipsets. Since NB-IoT is a lower end one, we were able to manage it in a reasonably low cost. Usually, smartphone modem kind of chips are a lot more expensive. They are $1 billion affairs. But I'm happy to say that this chip will be available for volume production soon, and you'll see it getting rolled out fairly soon. Yeah.
Thank you. I'm sure that there are certain questions. If you feel you can reply, but I think one last question I have from all the panelists, uh, that what needs to be done by we lead in the deployment and development of 6G. So this is open, I mean, to all, because I think government has taken a number of initiatives. They are, I think, going each way, like digital twin. We are doing in a phased manner and learning the how can we utilize this digital twin or one even 6G in decision making process also in running the smart cities. That is the just one example, but I think in every aspect of life. In addition, what is your expectation? What can be done at the Bharat 6G Alliance level? What can be done by the government? Different I'm government. I'm not referring to just Department of Telecommunications, because we'll be working with the space, DST, MIT, education, to name just a few. So if you just say that no, no, let us go there and work with XYZ department, including state government, because I think they will play a very bigger role in bringing the technology. They should not be just mere spectator that let technology develop and then only they start consuming, because we are thinking of being an innovator in the country. So please share what's your views. Each one of you can say, and that's a wish list. Nothing to do with their own institutions. I mean, one can't say that whatever you are speaking, that is your views. Okay. So first, let us start with the Jisnu. What is your thought process? Because I think you represent startups also here.
Yeah, so first thing I think, yeah, as Professor Kiran mentioned, there should be a lot of funding for academia because a lot of those research starts from academia. So, for example, terahertz is a completely academic research right now. So, this if academia doesn't do any work, like Radha is taking care of it, Samir, etc., we don't even know whether it is worth taking from a commercial perspective. So, some of this has to be academic research, and academia has to be funded quite a bit. Hopefully we better China in that, and academia gets funded. Similarly, startups, I think many of them, we know how usually it takes a long time for things to be developed in any technology. So they also need to be maybe angel funded and all that stuff. So that is one thing which needs to be done initially. And I think like IITM Research Park, maybe we have research park everywhere where people can start working together, collaborating together, and then they get initially funded. For a larger company like us or something, when you are, we need market access. We need larger market to deploy because there is no way to bring down cost unless you deploy in a larger number, and that is true for any technology. It doesn't matter whether uh, any startup to scale up and become a larger company has to have volumes, and the volume, luckily we have it in India. Any technology which we pick up, and this I can say over my past 20 years, the technology which India picked up, whether it is GPON, there was an alternate technology called GEPON. It never saw the day of light because of the volumes usually are done mostly either by India or China or both. So whatever we pick up as the technology, that becomes the norm globally, not just in India. So TD-LTE was something similar. The TDD was actually initially proposed by China, but the initial large deployment happened in India, and now this has become the appropriate technology not just for 5G, but even for 6G and other frequency bands. So all of these things, I think Bharat 6G Alliance has a role to play. And then finally, and we have to be aware of this, is about standard essential patent. I think the goals of 10,000 looks like a very big number, but yeah, if you see from an overall perspective, we are supposed to get 10% of all the 6G patents, because without that, we really don't have, we can get into real legal issues later in the day. So it's better to work now, create enough IPR, and I'm sure we can have some mechanism to pool this IPR where people can use it, figure out a mechanism for the business case of how do you pool and all that stuff can also be something which can be worked out under Bharat 6G Alliance. Thank you, sir.
Thank you, Radha.
So thanks. How do we make India the leader in 6G? One is we have to stay focused, sir. We have to be really, really focused with what are the goals that we want to achieve. And we have to be organized. Okay, while there's a lot of efforts going on, I still feel that we are a little bit disorganized in the way we are conducting things. I think all of them have to come under the same umbrella. We have to talk to each other much more and collaborate. I think that is a very key important thing right now. Third thing, as Jishnu pointed out, focus on standards. I think it is time to file the IPR. I think one thing when I'm talking to academic institutions, including IITs, a lot of IITs also, they have a very different view of IPR compared to what is there in standards. Okay, I mean, standards are not like papers. You really have to file standards by hundreds and thousands. I mean, this is what happens in companies. I think that we have to take that. I mean, while there are extremely good patents, there are lots of normal patents also which are required. I think we should start filing them ASAP, and there should be a general awareness that has to be created on filing patents in this particular area. And I think one of the things that I strongly advocate is that we have to start supporting our startups in big time. We have to take, I mean, maybe not all the startups, but we have to start identifying startups. I mean, start in a pyramid scheme, start identifying startups and start putting money so that by the time 6E comes, they are also ready. I mean, academic institutions can only take things to so far. I think after that, it's the job of companies, startups to really push this to become leader. I mean, if you want to become leaders, we have to have an Ericsson or a Nokia or a Huawei here. It's not like academic institutes can do this. Okay, so that is what we should focus on. We should start funding them. We should identify good startups and start giving them money. I mean, I think money should be spent on. I think if you do all this, I'm pretty sure that there's a good chance that we can have a good substantial stake in 6 years. Thanks. And I think Bharat Alliance actually should start playing a more leadership role in this, getting all of these people together. Because DOT is government, we're academics and other things. So I think it's job of the alliance to make sure all of them come together, start talking to each other, fighting with each other, and building up the 60 standard. Thanks, sir.
Thank you, Professor Kiran.
Thank you, Patak ji. So I have actually an assignment for you as my first suggestion. This is something I was talking to Radhakrishna when I was in UK. I think that we should immediately start a scheme to create 1,000 PhDs, and each PhD student should get 1 lakh scholarship, and identify the number of colleges. So the reason I'm proposing this is that you need critical mass. Today, you count how many people are there in India to build 5G. I don't think there are 500 people, hardly. I mean, experts. Okay, there are. You can name, you can count numbers, but uh, you need experts. Experts mean they, if you ask a question, they should know A to Z. So, what we should do is 1,000 PhDs to be started. So, this is a Bharat 6G skill program. 1,000 PhDs, 3,000 MTechs. This scholarship we should launch immediately. Get the funding. Just, I think you have plenty of funding in DOT. First, start that. This is the easiest thing one can do, giving money to universities. But when you do that, are super selective in recruiting the student, because the reason I suggested 1 lakh is that the PM scholarship is 1 lakh for PhDs. That is there today. So you can make it comparable, and then give a 15% year on year increment or some HRA. The reason I'm saying is that we live this life of working with students, and we lose a lot of them to other companies who are paying 1 lakh a month or 2 lakh a month. So we have to be brutal in just using the money to attract them. And I'm not saying that all of them will join, but this is a beginning. This is something that must be done. Second thing is there are about maybe 10, 12 startups, and no VC is going to fund them. I can give you in writing. Okay, anytime soon. Okay, in telecom, doing radio access network, because this is a hard business. If you don't fund them, if you don't nurture them, they'll all die. Okay, there's no Bharat 6G story left. Okay, so so make sure you ensure they are also national assets. Every startup company is a national asset. Okay, make sure they don't die. They have to prosper. Give them money. Okay, now I'm not saying because I have a company giving me money. I'm saying as an unbiased opinion because living this life. So give plenty of money to them. Good things will happen. At the end of the day, what do? They create jobs. Okay, that's what they do. They create jobs. So this is second thing. Third is what Radha said. The activities in 6G are fairly scattered. I think you know that MIT has been funding a parallel 6G but 5G advanced. There are also 6G projects. There's a lot of stuff happening in parallel. So I think, but we have to take stock of what is the total grant given, and we should scale it by a factor of 10, 20, even up to 100 if you want to make a mark. But this has to be done in the next 3 to 6 months. Okay. So you really have some assignments as a Bharat 6G Alliance. You need to get this thing done, sir, immediately. March 2025, 3GPP will start uh, 6G study item. Then there is no breathing time. We won't have time to talk like this. Once that starts, that will run till 2030. Okay, there's no time left. So we have to make use of the time between now and the 6G study item beginning and prepare ourselves in a very big way. Okay, I'll stop here. 1 year time is left. Thank you.
Thank you. I think you have given a lot of homework to me. Now, finally, I would like to just, I think, listen my colleague, Mr. Ashok Kumar, and whatever sir will be saying, it's not the views of Department of Telecommunication and the government. Your personal views that what should we do for a country, because even I have the passion only to drive these initiatives, how we can make 5G, 5G advanced and 6G from India. So with this, if you feel, you can just speak and just give this blessings, because a lot of persons still, I realize that it crossed 200, and that's why I stopped video and audio, because I was finding very difficult for the C dot, this one to, it should not crash. So I'm really thankful to all and would like to hand back to you, because I think we'll just like to have your views.
Yeah, thank you, Pathak ji, and thank you all the panelists, Professor Kiran Kuchi, Professor Ghanti, and Dr. Jisnu. So a lot of things have been said. So the suggestion given by Professor Kuchi is worth kind of implementing. And since now I also part of DOT HQ, so I'm aware that there is some talk on the line which Professor Kuchi said to sort of sponsoring the PhD in telecommunication field. So maybe if there is some write up and some detailing possible from him to be given to us in any formal or informal way, perhaps that will, I mean, consolidate what in DOT they are trying to conceive and do it. So that's again request back to Professor Kuchi, maybe through Pathakji or directly. Uh, and in that aspect, I don't know whether we need to look at what are the specific area on which we should do these PhD sponsoring, whether those need to be identified in advance or we can left it to individual institute to decide. So that is also something we seek guidance from Professor Kuchi. Maybe that will help. Maybe we can work with Pathak ji and the backend from Professor Kuchi and others. The other discussion which was happening about what are the area where India can excel, and a lot of good thing came out from all three of you. So, to my mind, what comes to my mind is like uh, even today, when I go to northeast and other hilly area, there are a lot of area where we don't have a mobile communication per se. There may be availability of some satellite-based uh, voice handset or maybe VSAT kind of environment, but actual communications for resident or citizens are not there, and perhaps how we can, like, although we are talking about integrating NTN as part of 5G advanced and 6G, so whether uh, the leadership role on that aspect can be taken by us in India, because we have a lot of requirement of that in many part of our country. So I don't know whether there's some work already going. There was some proposal in DOT, but I don't know whether it will see day of light or not. But perhaps we need to also work with satellite industry. For example, today, panelist one could have been from, say, satellite industry, so that we can also include, like in 3GPP now, satellite industry is becoming part of the standard making. So here in India also, perhaps we need to work more towards that. Initially, Pathak ji had asked one question related to like network for AI or AI for network. So in that aspect, what I am thinking that I mean whatever we do, I mean in the network that I mean the native AI things into the network, that's will of course is for 6G network. But whether you do that or not, AI application are already there and will multiply over a period of time, and the network which you are trying to build must support all those AI applications. When we say network should support AI application, one thing which comes to my mind that AI is very a data intensive thing. Like for example, a lot of metadata would be required to train the model and all, and those data has to flow onto the 6G network or the whatever network we have at that point of time. So basically, it will be a shift from a downlink intensive design of a network to a uplink intensive design of a network. So in that is also area perhaps one has to look while looking at designing of the 6G, that how we can support AI applications through the network. So that's the area. And there also comes, like, since we have to support a very high data rate and our spectrum resources are limited, so what kind of spectrum sharing techniques we should evolve, because that's very important. Spectrum is limited, all of us know, and as we go higher in the spectrum band, we have certain problems in the sense of it can cover very small area, and also the technologies we need to develop on that. So how we can utilize those lower band, mid band, upper mid band kind of the bandwidth in a better way, more efficient way, by having some new kind of sharing technique where I mean we can multiply the usage of the same spectrum multiple times. Uh, in regard to the funding and all, which Professor Kuchi talked about, like from DOT side, as you may be aware that as part of TTDF, a lot of recently, I mean, proposals were called for 6G related research, and we had received almost 300 plus applications from different companies, academia, and also the joint proposals, and that has been fast tracked in DOT, and perhaps very soon, whatever funding uh, is there would be going, and perhaps that will also accelerate some of the aspects. There are many other things going on, like you might have heard about 5G intelligent village, or 510 odd lot of villages we want to kind of develop applications over 5G, so that we can showcase. Today, although we have a 5G network, but other than EMBB, we have not been successful in doing applications towards other two usage scenario. But maybe this can create some buzz, and our service provider and other ecosystem can start developing some use cases, which was a primary thing for 5G and also 6G going forward. So with this, I would stop here. Sorry for being long.
No, no, sir. I think thank you. So I am offline working with the satellite companies. I told that don't wait for the release 20 for the unification of satellite and non-satellite. So I even visited Catapult in UK. A lot of work is going on. So we should also set up some test bed also, like 6G test beds. There should be satellite test beds. I'm working on that offline. And in addition, I think that's what I'm saying. People they realize that let's wait for along with the 3GPP. And I have the view. I'm working in the spectrum group also. Can we have some agenda for my WRC 31 and 35 if you have not done from India 27? Because I think being a technology leader it's very much important that we work something some 10 years advance in spectrum and different aspect. I think you referred that we have to do coexistence studies, dynamically sharing, so many things will be possible. So with this, I think I would like to thank you all. But at the last, I request my all Bharat Sikh Alliance officers, because they all work like Dr. Astha is there, Swapnil Tripathi is there, Samta. You all become online. So did I think people just realize that we are there, and Mr. Gyanendra Singh. So they work tirelessly. And within 1 week, we have been able to showcase that we can do this. I think it was more than 200. So these are my all staffs who are here, and I'm thankful to them that with their help we did this. And most important, it after 15 days, either on Thursday or maybe on Friday, we will again host some talk by at least two leaders, and that will be something like presentations, suggested, and it's all right now. Even today, sir, it's all online. You can just see on YouTube as well. And this will be hosted on my website, on my LinkedIn account, Bharat Alliance. I would like to thank you all and really grateful for not only panelists and others, but those who are participating for spending their almost 2 hours time. Even someone has joined at 9 today itself. I'm really grateful. But what my request is that please give me in writing also whatever you feel we can do. It's not that you become my member, even if you're not my member, because I have to work for the country, not for my institution. And that has been set up keeping that in mind. So I'm requesting you all that please write to me your problem statement, your solution statement, what is your expectation from me. With this, I would like to thank on behalf of Bharat Sikh Alliance to all of you. Thank you, sir. Thank you all.
Thank you.
You, sir. Thank you. Bye.
Thank you, sir. Thank you very much.